Welcome to this explainer. Today, we're diving straight into an absolutely awe-inspiring journey right inside your chest. We're looking at an organ that is both a miraculous mechanical pump and, honestly, the site of a hidden, microscopic battlefield. We'll start by checking out the macro structure of the human heart. You know, the powerful muscle, those elegant valves, and then we're going to zoom all the way down to the cellular level to really understand this secret, silent war that dictates our cardiovascular health. So, let's get right into it.
100,000. I just want you to think about that number for a second, because that staggering figure is the approximate amount of times your heart beats every single day, while you're sleeping, while you're working, and literally right now as you sit there, your heart is just working tirelessly. It's the ultimate living engine, a highly specialized muscular organ weighing roughly 300 grams tucked right behind your sternum, keeping you alive second by second without you ever even having to think about it.
Okay, here is our roadmap for today. We're going to cover 1. The ultimate living engine. 2. The electrical control center. 3. When the engine falters. And 4. The microscopic battlefield.
Section 1. The ultimate living engine.
You can really think of the healthy heart as this brilliant mechanical pump. It uses distinct chambers and precise one-way gates to build a continuous circulatory loop, and it all happens in 4 major steps. Step 1. Deoxygenated blood returns from your body into the right atrium, moving down into the right ventricle. Then, that right ventricle pumps the blood out to your lungs, which brings us to Step 2, pulmonary oxygenation, where the blood picks up fresh, vital oxygen from your alveoli. After that, Step 3. That freshly oxygenated blood returns to the left atrium and passes into the left ventricle. And finally, Step 4. The left ventricle, which, by the way, has this incredibly thick muscular wall, generates the massive pressure needed to forcefully eject that blood right out through the aorta, distributing oxygen to your entire systemic circulation.
Now, if we break down the clinical histology, or the tissue layers of the heart wall, we see 3 main layers. The endocardium is that thin inner lining that also covers the valves. The epicardium is your outer protective layer, but the myocardium, right in the middle, that is the true muscle doing all the heavy lifting. It's composed of specialized cardiac muscle cells that contract rhythmically to generate mechanical force. And here's a wild fact. While a normal heart weighs about 300 grams, the myocardium of an elite endurance athlete can actually hypertrophy, meaning it grows, and increase the heart's mass up to 500 grams just to handle the extra workload.
Section 2. The electrical control center.
But look, muscle alone simply can't do the job without instructions and resources, right? The sinus node, or SA node, is the main pacemaker of the heart. It sits right up in the right atrium and rhythmically generates an electrical discharge about 70 times a minute. Think of the SA node as your engine's built-in spark plug. Special pathways carry these electrical impulses across the muscle cells, setting the pace for the whole system. Honestly, in the short time you've been listening to me, your own SA node has already fired dozens of times, sparking perfectly coordinated waves of contraction.
But there is a catch. If the top and bottom chambers squeezed at the exact same time, the engine would completely stall out. So the crucial structural masterpiece here is this momentary delay orchestrated by the AV node. Tucked in a small area called the triangle of Koch, the AV node receives that electrical signal from the top chambers and just pauses it. For a split second, it ensures that the atria have time to completely empty their blood into the ventricles before the ventricles actually contract. It's perfectly timing the engine to prevent a misfire.
Now, here's an interesting problem. Even though the heart is constantly full of blood, that thick myocardium can't just absorb oxygen from the blood inside its chambers. It needs its own dedicated fuel lines. Resting right on the surface of the heart are your coronary arteries. The left main coronary artery is massive. It actually supplies 80% of the blood flow to the heart muscle before branching off into the LAD and circumflex arteries. Meanwhile, the right coronary artery handles the rest. If these specific fuel lines get blocked, the engine gets starved of oxygen.
Section 3. When the engine falters.
Let's pivot slightly and slow the pace down for a minute, because we really need to discuss what happens when this perfect, beautiful machinery breaks down or when it faces an internal threat. We typically see several major categories of heart disease. You've got arrhythmias, which are essentially electrical wiring problems. You've got heart valve diseases, where those precise one-way gates become too narrow or leaky. There's cardiomyopathy, where the muscle itself becomes stiff or thickened, plus congenital issues and even pericardial issues, where the sac around the heart gets inflamed. But that top bullet point, Coronary artery disease, the narrowing of those vital fuel vessels, represents the most common and pervasive threat to the engine. And to understand why that happens, we have to look much, much closer.
Section 4. The microscopic battlefield. We're zooming the lens all the way in now, past the macroanatomy of chambers and valves, right down to the cellular level inside the walls of your coronary arteries. Because this is where we find the literal biological warfare that drives coronary artery disease. To understand this battlefield, you need to meet the commanders, cytokines. Cytokines are basically low molecular weight proteins secreted by immune cells to regulate inflammatory and immune responses. You can think of them as the critical signaling flares and chemical orders that control your immune system's troops on this microscopic battlefield. They dictate where cells go, when they attack, and when they stand down.
Now, I really want to clear up a common misconception here. People hear about atherosclerosis, the buildup of plaque in the arteries, and they tend to think of it as this passive process, kind of like grease slowly clogging a kitchen pipe. But it is definitely not just passive clogging. It's a chronic inflammatory disease. It's an active, aggressive war zone inside the arterial wall, triggered when modified, oxidized cholesterol gets trapped in the tissue and sets off a massive immune response.
Inside your arteries right now, there's a literal dichotomy of conflict. It's a war between two opposing cytokine forces. Over on one side, we have the pro-atherogenic forces. These are the inflammatory instigators like Th1 cells, IL-1, and TNF-alpha. On the flip side, we have the anti-atherogenic forces, the cellular peacekeepers, like regulatory T cells, IL-10, and TGF-beta. Let's take a quick look at their tactics.
First up, the instigators. Cytokines like TNF-alpha and IL-1 actively damage the vascular barrier. They literally disrupt the junctions between the endothelial cells lining your blood vessels, and once that wall is breached, they recruit more immune troops into the tissue. They actually accelerate the transformation of your basic macrophages into these swollen, toxic things called foam cells that just gorge on oxidized cholesterol. These instigators are constantly destabilizing the plaque, weakening the protective cap, and pushing the entire engine toward a potential plaque rupture and a heart attack.
But thankfully, there is resistance. Enter the peacekeepers. Anti-inflammatory cytokines like IL-10 and TGF-beta work tirelessly to suppress this battle. They promote the expansion of regulatory T cells, or TRAGs, which are essentially the diplomats of your immune system. These peacekeepers inhibit those attacking pathogenic lymphocytes. They maintain self-tolerance, and they reinforce and stabilize the entire plaque environment, desperately trying to protect the vessel wall from rupturing. It's incredible when you think about it.
Which leaves us with a pretty critical final thought to wrap up this explainer. You have an absolutely incredible 100,000 beat-a-day engine inside your chest, and there's a microscopic war raging within its fuel lines right now. So the question is, are you protecting your engine and supporting those microscopic peacekeepers in your own inflammatory war? Through your diet, your exercise, and your lifestyle, you actually have the power to influence this cellular battle. Thanks so much for joining me on this deep dive. I hope you walk away with a profound new appreciation for the ultimate living engine inside you.